This is a nodal analysis method. Nodal analysis method is Kirchhoff current law. The first node shown is node 2, which I name it for finding V2. V2 node came across the voltage source 1, hence V2 is equal to 30 angle 130 volt. So V2 can be substituted into other node equation. The second node shown is node 1. The node 1 equation is shown below. The third node shown is node 3. Node 3 has a current in and 3 current out. This is node 3 equation. Since we use Kirchhoff current law, the current in of 8 ampere can be used directly. The last node is node 4. The equation shown is for node 4. Then, we use Cramer's rule to solve the linear equation of node to find V1, because V1 is the voltage across R4. First of all, find the determinant of the coefficient, which is the answer shown below. Then, substitute the answer of the matrix into the element of V1. Thus, we find the determinant of V1. Therefore, determinant of V1 is divided by determinant of coefficient to get the value of voltage across R4. Lastly, by using the Ohm's law, we can find the current flow at R4.
This is my analysis method to solve the problem for the circuit. This is the circuit that designed by us based on the question given. The question is, we need to find out the value of voltage that flow at the resistance number 4. The purpose of using mesh analysis to find out the volume of the current for every each of the loop. For the mesh analysis, the first step we need to know is the flow of the current. In this diagram, we decided to make the flow of current counterclockwise. For this method, we need to apply Kirchhoff's voltage law by increment of the Ohm's law. The equation given is the value that we determine for every each of the loop. Based on the equation given, we know that the value for the I1 equals to 8. Right now, we're going to derive the value for the I1 for every each of the loop that contain the value of I1. Based on that, we can lessen the quantity of the equation that we need to use. After we derive the equation given, right now we can use the Cramer method to solve the problem. By using the Cramer method, we can solve the volume for the total determinant, determinant I3, determinant I4. This is the calculation for solving the problem. Right now we can get the value for the I3 and the I4 by divide it with each of the equation with the total determinant. I3 must be minus with the I4 to get the volume of current that flow at the I4. After that, we could use the Ohm's law by timing I4 with the R4, and we get the voltage that flow at the resistance 4.
This is another method to find IR4 and VR4. The value of Zn is equal to the value of Zth. This is the Zn value that we get from the Thevenin method. After that, we need to find the value of In by using mesh analysis. To get the value of In, we need to replace R4 with In. This is mesh analysis that we get. We get 4 loop. Because of our looping is anti-clockwise, so the value of In is I3 minus I4. At the loop 1 that has current source, so the loop 1 definitely we get 8 ampere. Next, this is looping for the loop 2. This is equation for the loop 2. Then we derive the equation and we get the final equation for the loop 2. Next, we need to find the equation for the loop 3. Then this is equation for the loop 4. This is all equation that we get for the loop 2, loop 3 and loop 4. To get the final answer for the I3 and I4, we can use the Cramer's rule. First, we need to find total determinant. Then we find determinant for I3. We can get for the final answer the I3 by using this formula, determinant I3 over total determinant. This is final answer for I3. After that, we find the determinant for the I4. We can get the final answer for I4 by using that formula, which is determinant I4 over total determinant. This is final answer for I4. To get IN value, the value of I3 must minus value of I4. This is final answer for the IN. For Norton's theorem, we need to create new circuit to find IR4 and VR4. From the circuit, we can use current divider rule to find IR4. This is the final circuit that we get from the source transformation. From the circuit, we will get the value of VTH. We can use voltage divider rule formula to find VR4.
Hi, I'm Arif from Group 8. I will show you on Thevenin theorem based on this circuit. So the value of V1 and V2, I1 is based on this one. The capacitance that's value will calculate based on this formula. So first we remove all source and find ZH. Will become this circuit. Note that I equal to 0 will become short circuit and V equals to 0 will become open circuit. Second, we combine capacitor C with R2 with C, so we plus it, and this is the values. If possible, sign R2, R3 and L1 with A, B and C respectively to make delta star configuration of the step. The third one is the delta star configuration circuit. It will be like this, followed by the formula for star configuration. This one. So the answer should be like this: A, B and C. For example, we want to find A based on the circuit at number 2. We combine A and C, resulted A star. By replacing formula RB times RC to RA times RC. The denominator stays the same, followed by the others. Next, this is the equivalent circuit based from the previous calculation. So ZH, we parallel A and B and series with C. Fifth, we apply mesh analysis and find VTH. So mesh can be done by apply 3 loop with this one, and this one. So the equation loop 1 just take the current source 8 ampere. The direction of the loop is inverse to the current flow, thus 1 will be -8. Sorry. For the loop 2 should be like this, as it loops around this circuit only. Same for the loop 3. Loop 3 covered by this area. So this is the equation for loop 3. After that, we apply the Cramer's rule and find each of determinant that we get in 1, 2 and 3. So this is the equation, and we find I2 and I3. Next step is find voltage R3 and VTH at this area. So the calculation of VR3 voltage R3, we get the value of this one, and draw equivalent circuit to find VTH. It will look like this. The calculation resulted with this equation. So the last step is draw a Thevenin equivalent circuit by using voltage divider rule to get VO at 8 ohm R4. So this is the value of VR4. Last but not least, by using Ohm's law, V equal R, we get the value of current across VR4. So this is the simulation of our group. That's all. Thank you.